Okay, so hi everyone. Today we're going to solve another problem, that is LeetCode 1833 maximum ice cream bars. It's a medium problem, and in my opinion it's a simple greedy problem. It's not that challenging and you won't be learning anything new, but it is a good problem. I think in most of the contest a lot of B problems are designed with these problems, and it's a good standard greedy problem. So yeah, it has a good like to dislike ratio, although not spectacular, but yeah, still fine. So it is a sweltering summer day, like it's a very hot day, and a boy wants to buy some ice cream bars. Okay, at the store there are n ice cream bars. You are given an array cost of length n, where cost I is the price of the ith ice cream bar in coins. The boy initially has coins. Okay, he is given some amount of coins to spend and he wants to buy an ice cream, as many ice cream bars as possible. Okay, return the maximum sorry, return the maximum number of ice cream bars the boy can buy with the given coins. The boy can buy the ice cream bars in any order, which means, well, if this is the line, then it certainly signifies that we can change the order of the cost array. Like for example, we can buy the fifth ice cream bar and then second, then first, and then so on. So you are given this cost array 1, 3, 2, 4, 1, and this is the given coins that you have. So that's like a representation of 1, 3, 2, 4, 1, and you have yeah, so you have 0 ice cream bar. This is first, this is second, this is third, and this is fourth ice cream bar that you have with yourself. Now, the total number of coins that are given to you, right? The money or the coins that are given to you is 7. So now you will make a choice that should I buy this one or not? And you will say that this is a okay, so this is a very basic intuition that you must have. If you will buy all the ice creams, all those ice creams which have lower price, in that way you will be buying the maximum number of ice creams, right? So what is the proof for that? So let's say we sort these elements and now we have 1, 1, 2, 3, 4, right? The lower ice creams, so these are the cheap ice creams, and as you go on you will find expensive ice creams, right? So if you will buy all the cheap ones, then you will have more quantity, but if you'll buy the expensive ones in an expensive, like the priority is to buy the expensive one first, then you will have less quantity of ice creams. How to prove that? So for example, if you are on ith ice cream, right, there are two conditions: that the I plus 1th ice cream cannot be bought. Why? Because the coins that you have with yourself, the coins that you have with yourself is less than the cost of I plus 1 ice cream, or the I plus 1th ice cream can be bought, which means the coins that you have is either greater than or equal to cost of I plus 1th ice cream. Now if this is the case, that the I plus 1th ice cream the cost is lesser than that, which means all the ith 0 to ith ice cream that you have bought are the maximum items that you can buy, because after this I plus 1 you will have I plus 2, you will have so on elements, and none of them can be bought, right? But if this is the case, then you can bought the I plus 1th element, and then you will make choice for the next element, that is I plus 2, if this can be bought or not, with the same condition that if it is, if the cost that you have, if the coins that you have is greater than, is lesser than the I plus 2 cost, the I plus 2th ice cream cost, then you cannot buy it, and the items that you have bought are the maximum number of items that you can buy from the given coins. So this is basically a greedy problem, and in most of the greedy problems, the problems are based on sorting. So first of all, we are going to sort the array, cost dot end. Now you will have a bars that is equal to 0. Now you will have let's say cost from costs. Now if the given coins, if the coins that you have are less than the cost, then we will simply break. Why? Because all of the cost of the elements will be greater than that, so there's no point of um, checking all other ith ice creams when you have encountered an ice cream that is greater than the cost that you have, that is greater than the coins that you have. But if it is not, then what we can do is coins will be subtracted with the cost, right? And the bars will be added, and then you will return bars, the ice cream bars that you have gathered. As far so good. So let's see if this will be submitted. If it is not, then we will try to debug it. Okay, it is submitted, and it is fine. It's not performing ideally good, but yeah, it is quite okay in my opinion. It's an average solution. So the time complexity for this one will be time for this one will be n multiplied by log of n, right? So n into log n. Why? Because the sort function will be order of n multiplied by log n, and this is a linear function, so this will be order of n, right? And yeah, now there is another solution which doesn't require sorting, but it's kind of like a relatively it's an optimized one, but I don't know why compilers are not behaving as such the theoretical part. So the solution takes more time than the sorting one, but I still think that in the theoretical analysis of time complexity, it is the more optimized one. So how to do it? First of all, we need to find a max element. So max element out of this would be pointer max element cost dot begin cost dot end. After finding this max element, by the way, this max element processing will be linear, so this will be n. Now after finding this max element, I will have a vector of count. So the number of for example, we have 1 here, right? How many count do we have of the ice creams that have the cost 1? That will be stored in the count vector, and the maximum size and the size of this will be maxl plus 1 and initialized with 0. And we also need bars that is initialized with 0. Now we will have int cost of costs, and we will initialize the count vector with the count of all these cost of ith ice creams and plus plus. Now so I is equal to, so now we will say cost is equal to 1, cost is less than equal to maximum element, and cost is incremented. If the count of cost is equal to 0, then there's no point of processing it because we don't have any ice cream there. So we will simply say that continue our loop with the another cost of that is 2, 3, 4 or anything, or the I plus 1th cost. And the other case that is dangerous for us is if we have the coins that are less than the cost value. If this is the case, then simply break out of it, because we cannot have any bars that are any bar that have more cost than the coins we have. That is very common, right? And this will, by the way, this will also be linear, and this will also be linear time complexity. Yes. Now there's a processing part. So now bars quantity, the maximum bars that you can have is minimum of, so minimum of the count of bars. This is the possible bars that you can have. The count of cost will give you the maximum available number of bars in the shop, right? And but if that's not the case, you cannot have the maximum bars. Your coins are limited, you can only purchase few of them, right? What is the formula for that? So for that you will say that the number of coins that you have divided by cost, right? This will give you the maximum bars. So this is the maximum bars that you can have. Let me write the comment here. So it's minimum of maximum available bars in the shop, right? Maximum available bars in the shop, or maximum bars that the user can afford based on the coins available, right? So this is the formula for that. And then after having this formula, you will decrease the coins, and that is equal to the count or let's say count, not count, actually cost multiplied by the bars quantity that you have, chose to purchase. And the bars that you will have will be added into the bars. So the bars quantity will be added to the final bars, right? And then you will return the total bars that you can gather. So now this solution will take somewhere around, this is also n, and yeah, the quant even though the constant of this will be like 3 of n, right? It's 3 of n, and here we have just n, this is also n, this is okay. So 1 2 3, and this is 7n. So this solution will take 7 of n, order of 7n time. Well, but the log n, that is the n log n solution, the sorting one, the maximum time that it will take will be equal to 16 into, because log base 2 of 10 raised to the power 5, that is the maximum, and the maximum n that can be will be 16 into n. So but this will be 7 into n in all of the, regardless of the n value. So this will perform better if the n value is high, but for the lower n values, for example we have 100, I think log base 2 of 100 will be something similar to 7n or 6n, so which is why, or 5n maybe, I don't know the exact value of log base 2 of 100. But the sorting solution will perform better in lower n values, and the this solution will perform better when you have high n values. For example, 10 raised to power 5, 10 raised to power 6, and something like that. And this is also a catch: if you have 10 raised to power 6, then it will give you a runtime error, because we cannot have a vector or array that is of size 10 raised to power 6 or 10 raised to power 7. So yeah, there are some limitations to this solution, but the sorting one doesn't have any limitations, and it also have a space complexity. The space complexity will also be equal to order of n, whereas the sorting solution will not have a space complexity, it will be constant space solution. So yeah, this is the solution. Let's see if this will be submitted. Yes, it is. And it is performing quite well as compared to the previous one, the sorting one. So yeah, this is the problem. I hope it would have helped you, although there was not a lot of stuff to explain in this problem, because I have said earlier it's a like very standard greedy problems, and greedy is the topic that everyone starts with. So I don't think there's any more explanation to this, although I have given you the link of the problem if you want to try it out, and the code, and I have also given the solution that I have explained in a theoretical manner on the LeetCode. You can also check it out. So yeah, thanks for watching and have a good day.